Hello everyone, in this video we're going to go over solving inequalities. We're doing this today because we solve these exactly like we solved equations, but there's going to be one tiny thing that's different in only certain situations. Before that, let's go over the types of inequalities as a short review. The first two symbols are less than or equal to, or less than. The reason why this one is less than is because in America, we read from left to right, so 5 is less than 7. This one points towards the small number. I'm sure you remember those. Now let's talk about the opposite version, and that would be, and once again, the reason why this one is called greater than is because Americans read left to right. So you would say 6 is greater than -3. Or 2 plus x is greater than or equal to 4. The new part for this lesson is that whenever we're solving inequalities, whenever we're solving the inequality, we still want x by itself. So if I take that 2 plus x is greater than or equal to 4, I'm going to subtract the 2, and that'll leave me with x is greater than or equal to 2. In the original inequality, 2 plus something is greater than or equal to 4. I can put anything in this parentheses as long as we can put anything inside of that parentheses for x. As long as it's greater than or equal to 2, the inequality is going to be true. So if I put 3, it works. If I put 10, it works. If I put 1, 2 plus 1 makes 3. 3 is not greater than or equal to 4, so this would be false. So we can't put 1 because that would give us a false statement. But if we put 11, then that would make the inequality equal to 13. 13 is greater than or equal to 4, so that would make a true statement. And that's how you plug these in. The only thing on top of that you need to do is, since x can be anything that's greater than 2, it's not just a single answer. Since there is more than one answer for this question, we need to make a graph for the answer. It's easier to graph the answers to the inequalities than it is to just read it and know exactly what it means sometimes. So if I was going to graph this one right here, x is greater than or equal to 2, then that means I need to have the number 2 on a number line, and then you need something smaller than 2 and something greater than 2. So the something smaller than, I'll put -1. For something greater than, I'll put 10. Then we're going to draw a number line. If you can be the number 2, we're going to put a dot above the number line. And we're going to be things that are greater than 2, so I'm going to be everything on this side and nothing on the left side. That is my answer. Let me do another example. W divided by 2 is less than 5. We're going to solve it like normal by multiplying by 2. The 2's balance out. That leaves you with W is less than 10. W is less than 10 is one version of the answer. But since it is an inequality, we should also graph it. And if I need to make a number line, then I need my line. I need to have at least the number 10. And one thing smaller than it, I'll put 0. One thing bigger than it, I'll put 20. And then let's go. Can I be the number 10? I can't be the number 10. It says I have to be less than 10. So we're going to put not a dot. A dot means including. A circle means we're going to be the numbers right next to this one. We're going to be right next to 10, but we can't be 10. And we have to be less than 10, so we're going to be the numbers on the left side, which is everything less than 10. Like we got this 0, you would have 5, you could be 9, you could be 9.9, you could be 9.999. You just can't be 10, you have to be less than 10. So that's the second version of the answer. And let's write down why those things are. If there's only one variable, then the graph is going to be a number line, and the open dot means not including. And we use that not including symbol whenever it is greater than or less than. A closed dot means including that number on a number line, and it is used whenever you have greater than or equal to or less than or equal to. I'll do 2 more examples. $12 is greater than y divided by 9. To solve this like normal, we multiply by 9. These 9's on the right balance out. Y is less than 9 times 12. 9 times 10 is 90. 9 times 2 is 18. Add those 2 things together, you get 108. Y is less than 108, or you could read that as 108 is greater than y. On the number line, we need to make that line. We need the number 108 on there. We need something bigger like 110. We need something smaller. We'll throw 100 on there. We need the numbers bigger than 108. We can't be 108 because we're not equal to it, but we just can be anything that's bigger than it. There's a number line. You would read that as y is any number larger than 108. The last example had to be split into another video because otherwise this would be too long.